In this video, we're going to look at calculating some finite summations. So some more terminology is the concept of series. A series is just the summation of the terms of a sequence. So summation and series are synonyms. Series can be finite, which means there's a number on top, or it can be infinite, which means obviously that there's infinity on the top. When we're calculating an infinite summation, what we usually do is find the partial sums. So I would look for patterns there. So if I was trying to find this infinite summation, I would find the first partial sum, which would just be 3 over 10 to the first power, or 0.3. I can find the second partial sum, which would be 3 over 10 to the first plus 3 over 10 to the second, which would be 0.33. I would find the third partial sum, which would be 3 over 10 to the first, plus 3 over 10 to the second, plus 3 over 10 to the third, which would give us 0.333. So hopefully you're starting to see a pattern. So let's say s to the 10th would be, so then we can kind of see from the pattern that my infinite sum would just be 0.3 repeating forever, or 1/3. So these would be considered my partial sums until I get to here, which is my infinite summation. All right, so if we just look at a kind of a traditional problem, find the sum of the first 100 positive integers. So really think about what they're asking us here: 1 plus 2 plus 3, etc., until I get to plus 99 plus 100. So there's a story in the history of math that this problem was presented to a third grader, and the third grader solved it this way, by writing it out sort of this way, and then underneath it we're going to write it out backwards. So this is 100 plus 99 plus 98, etc., plus, and then this would be 2 plus 1. So then if we think about adding each of these columns, we get 101 plus 101 plus 101, etc. So then what I would have here would be 100 101s, which gives me 10,100. But that's the black numbers plus the green numbers, and I only wanted the black numbers. So I'm going to divide that by 2 and get 50,050. So kind of a quick way to deal with this. So this process actually works for any arithmetic sequence. So anytime I'm summing an arithmetic sequence or doing an arithmetic series or summation, I can use this process. So if we generalize this process, what we actually did here is to find the finite sum, we took the number of terms times the first term plus the last term, and then divided by 2. So usually in the formula we write that n over 2, and then first term plus last term. And then also remembering that we have a formula for this a sub n here, so I can rewrite this formula: s sub n equals n over 2 a sub 1 plus, and then plug in the explicit formula for a sub n, which is a sub 1 plus d times n minus 1. And then if we just simplify that, we get s sub n. So the finite summation is n over 2. I have 2 a sub 1 here, so 2 times a sub 1 plus d times n minus 1. So I end up with 2 different finite summation formulas. So I have this finite summation formula and this finite summation formula, and I can use either one just depending upon what information I have. So for this first one, we need the number of terms, the first term and the last term, and for this one, we need the number of terms, the first term and the constant difference. So for both of them, we need to know the first term and the number of terms, and then it just depends whether you have the last term or the constant difference. So adding to the chart here, we had the explicit and recursive formula rows before, so now we're adding the finite summation. So these are the 2 formulas that we just talked about, and then we have the formula for geometric summation, and we're just going to go with, trust me, that's the formula. Be careful here that when you put this in your calculator, you need to have parentheses on here. Also, sometimes you might see this formula written slightly differently, so g sub n 1 minus r to the n over 1 minus r. So either one is fine, just as long as you're doing the subtraction in the same order in the numerator and the denominator. So again, remember you'll have this chart on the test and exam. So here we want to find the sum. So the first thing that you want to do is look at your sequence or series and decide, is it arithmetic or geometric? So I'm going from 2 to 5 to 8 to 11, so it looks like I'm adding 3. So I'm adding 3, which tells me that it's arithmetic. So now what I want to think about is, what do I know? So I know my first term is 2. We decided that we're adding 3, so my constant difference is 3. So I know my first term and my constant difference. I know my last term is 29, so a sub n is 29. For either of the formulas I have, I need to know the first term, the number of terms, and then either the constant difference or the last term. So right now I have everything except that number of terms. So what we need to do is use the last term to help us find that calculation. So we're going to find the position for that last term, which in this case is 29. So in order to do that, I'm going to use the explicit formula. So I'm going to plug 29 into the explicit formula. So 29 equals first term, which is 2, plus our constant difference, which is 3, times n minus 1. And then we can just solve for n there, and then we get n equals 10. So now I can come back here and I can use either one of these two finite summation formulas because I know that it's arithmetic. I'm going to use this first one because it looks a little bit easier. So my finite summation formula is n over 2 times first term plus last term. And now I have all of those pieces of information. So 10 over 2 times first term, which was 2, plus our last term, which was 29. And that's going to give us 155. Same question here, but it asks us to write this in summation notation. So once we write it in that summation notation, then we can use the calculator instead of trying to use the formula. So if we're going to write in summation notation, remember we have to know the explicit formula and we have to know the position of the last term. So similar to what we had before, we need to decide that this is arithmetic. And then what do we know? We know the first term is 2, and we know the constant difference is 3. So my explicit formula would be a sub n equals 2 plus 3 times n minus 1. What I need to know still, regardless of using the formulas like we did before or the summation notation, we have to know that position of the 29. So we got to find the position of 29. And just as we did before, we would use that explicit formula, and we're going to get n equals 10. So once I have that, then I can write the summation notation. So sigma n equals 1 to 10, and then my explicit formula goes here. So 2 plus 3 times n minus 1. And then I can just put that into my calculator using the summation notation to find it. And again, we get 155. Here's a similar example. We're going to write this using summation notation, and then assuming the pattern continues, we're also going to find the sum. So when I look at this, I'm going 5, 15, 45. So this one appears to be geometric, and I'm multiplying by 3. So again, what do I know? I know that my first term is 5. I know that my constant ratio is 3. What I need to know is the position of this last term. So we're going to find the position of 98,415. So remember, to do that, we're going to use the explicit formula. So 98,415 equals 5 times 3 to the n minus 1. So here, in order to solve this, we're going to have to use logarithms. So remember, first thing we're going to do is divide by 5. This will give us 19,683 equals 3 to the n minus 1. Using your logarithms, you're going to go, this is log base 3 of 19,683 equals n minus 1. So this is 9 equals n minus 1, so n equals 10. So now I've got two options. I can use my formula, or I can do the summation notation. So I'll do both ways. So if we're going to use the formula, so my formula from my formula sheet is first term times r to the n minus 1 over r minus 1. So my first term here is 5, and then we're going to go 3 to the 10th minus 1 over 3 minus 1. We get 147,620. So if I prefer, I can write this into the summation notation and get the sum that way. So in the summation notation, n equals 1 to 10, and then remember this is the explicit formula after this. So this is 5 times 3 to the n minus 1 power. Remember, in your calculator, you need the extra parentheses there. And you can see that we end up with the same answer that we got the other way. So no preference between using the formula and the summation notation. It really just decide whichever one you prefer better. Regardless, you have to find that n value.